Okay, and we're going to go ahead and talk about how we write electron configurations. In the previous video, we learned how to write orbital diagrams, which are basically electron configurations, but they're more expanded. This one is going to be a little bit shorter, and eventually we have another shortcut that we will teach you towards the end of this. So what I would like you to do if you're at home, you need to look at the periodic table in your notes, and what I had the kids do in class is actually fill in these first two columns with a certain color, and I use red. And make sure you know helium actually fits over here. So when we're talking about configurations, helium actually fits over there. Now, we had the students fill in the P block, this blue color over here, and we had them label it as the P block. And then in the center, we had them label the D block, and we had them color it, and then the F block is down here. So remember, I'm gonna write in a couple things. For the n quantum numbers, you'll see them over here. So n equals 1, n equals 2, n equals 3, n equals 4. These are the principal quantum numbers. And remember that L, the second quantum number, if it equals 0, that's the sphere shape. If L equals 1, that is the P shape. L equals 2, that is the D, donut or daisy shape. And then L equals 3, that would be down in the F block, and that would be the F shape, which is fancy or flowery shape. All right. One thing to note that I tell my students is that on the left side, n goes from 1 to 7. It's perfect. But what do you notice about this guy right here? He doesn't fit in the fourth row like the other ones to the left do. He is actually in the third energy level, and then it goes 4, 5, and 6 after that. And then what you notice is that in the F block, these two squeeze into the table right here. So I have my students kind of draw some dots there or some lines to kind of show that that's there. So what happens is it goes from the 6th row and it actually drops 2 energy levels down to 4, and we'll see that eventually. Okay, so let's try to do an electron configuration for the element carbon. So we're looking for carbon. So you got to find it on the table. Carbon is element number 6, atomic number 6. It's got 6 protons, and we're going to assume that it's neutral, which means it has 6 electrons. So I'm trying to write an electron configuration for carbon, and this is how I do it. I'm going to read from left to right, just like I'm reading a book, and from top to bottom. So I'm going to start here, always. So the first thing that I am going to write is the principal quantum number. So I'm going to start, first part is the letter N, second is my principal quantum L, and then this tells me the number of electrons that I actually have in that orbital. So here we go. I'm going to start at hydrogen at 1s, it's the first row, S block, and I'm going to go ahead and include both of these elements, hydrogen and helium. If I keep reading like a book, I hit the second row, still in the S block, and there are 2 elements there. Now, when I keep going, I hit the P block, still in the second energy level, and I only want to go to carbon. So I'm going to say 2P, and we get to 2. And this is the final electron configuration for carbon. Okay, let's go ahead and do some more examples. Let's try these 3. I want helium, which is here for electron configuration's sake. I want sodium, and I want titanium. So these are the three that I want to get. So let's do helium. Helium is 1s2, and that's it. It's a very short electron configuration. Sodium would be 1s2 for the first row, S block, 2s2, lithium, beryllium, 2, I'm still in the second row, 2, but I'm in the P block for boron, carbon, nitrogen, oxygen, fluorine, and neon, that's 6. I keep going until I get to 3s, and I'm going to stop at 1. Titanium, we would have 1s2, 2s2, 2p6. I'm going to pass sodium and say 3s2 for magnesium there. I'm going to keep going into the 3p block of Al, Si, phosphorus, sulfur, chlorine, and argon, which would be 6. I get to 4s2, and then something happens here. I hit the D block right here, and instead of going 4D, it actually drops down to 3D, and titanium is going to be the second element there. So be careful. That is an exception. All right, and we're going to finish this video by doing just a few more so that you can see the practice problems here. Fluorine, calcium, and copper. Fluorine, 1s2, 2s2, 2p5. Calcium is going to be 1s2, 2s2, 2p6, 3s2. And we're going to keep going to 3p6, and we're going to finish at calcium at 4s2. Copper would be, let's change colors there, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Be careful, there is an exception here, 3d, and we're going to count 1, 2, 3, 4, 5, 6, 7, 8. Copper would be the 9th one in that row. Okay, that is electron configuration.